Hi everybody, I'm here to talk about a tool that I've been developing using Windows Visual Studio. This program is called PCB Gcode Toolkit. I've been building this program because I like to build my boards, my PCB boards in Eagle. Here's an example of a board I just recently designed. Using the PCB Gcode ULP, you can create a couple Gcode files for drilling and etching the PCBs. This is a single layer board, and so it has spit out two Gcode files. I've renamed them drill.gcode and etch.gcode. So this is the example I'm going to use for the PCB Gcode toolkit. So these are straight out of the program, out of Eagle, I'll go through each of the tools that the toolkit has. So when you drag the Gcode file onto the .exe file, we get this display. So first thing is the Gcode file that you put in is drill.gcode. That's the correct file. Next, there's some statistics. The total time to drill the board would be about an hour. That's 3,642 seconds. Total distance is 1.8 meters. The dimensions of the board, Z, min, and max. And here's the list of commands or the list of tools that you can use. Some of them you can't use on a drill Gcode. You don't use the etch tools in the drill Gcode, and conversely don't use the hole drill tools on the etch Gcode. But I'll go through these one by one. So the first interesting one to look at is the draw Gcode path. So if I push D, we get this diagram. So this is a drawing showing the Gcode path. Now, I'm not sure how Eagle chooses the order of the holes to drill, but it seems to be one of the most inefficient paths possible. So it starts off here, for instance, and it goes down to some adjacent, and then holes, and then it goes all the way up to the top, and then all the way to the bottom, and then we're scooching over to the right. It's very inefficient. So you can leave this. You don't have to close this while you're using the tool. I'm going to leave it up, and I'm going to go over here. There's two hole drill optimize tools. So there's the divide and conquer algorithm and the genetic algorithm. The divide and conquer algorithm, it basically divides the board into different sectors and then uses either the genetic algorithm or a brute force algorithm, depending on how many holes, to create the most efficient path through all the holes. So basically, those are the two traveling salesman algorithms. The genetic algorithm tool here, it just leaves the board whole and applies the algorithm to the whole board. So it can take more time to process the whole board. So for time's sake, I'm just going to show you the divide and conquer algorithm. I'm going to go ahead and push O, and it's going to process all the holes. I think it's divided the board into 8 different sectors pretty quick. Now you can see it went from an hour, 3,600 seconds, down to half an hour, 1,774 seconds. My mill is not very fast, it's pretty slow, so that's one of the reasons why it takes so long to drill all the holes. But it's divided the total Gcode distance in less than half, so it's down to just under 900 millimeters. So I'm going to push D for draw, and you can see it's a much more efficient path. It's not the most efficient. There's still some unfortunate decisions made, but it's much, much better than it was before. The interesting thing here is you can push U to undo the previous action. The way that works is that the program creates a backup file. So every time you execute a command, it creates a backup of all the previous Gcode files, and then you push U, it just moves one previous. So as many commands as you execute, that's how many times you can undo it. If you close the program without pressing escape, like it says here, press escape to exit, then it'll leave that backup file there. I'm not concerned about that, so what I'm going to do is I'm just going to push escape, and it's going to close the program. Now we're on to the etch. So the etch Gcode. One of the things I've noticed with PCB blanks is that they're not level. So I have a function on my PCB milling machine to generate a probe grid. So it'll go around, it'll touch the PCB in several points in basically a grid, and it'll spit out this file. So you can see it's probing. Here's the X, Y, Z coordinates of all the probes. X from -45 to basically 0. Y from 30 all the way down to 0. And here's our Z. You can see it varies by about 0.01 or 0.1 millimeters, give or take. So with that file, I grab the probe.txt file. It can also be a probe.csv file. It can be whatever you want to call it, .text or .csv. And the etch.gcode file. I'm going to drag them both onto the PCB Gcode toolkit. So now you can see we have the Gcode file as etch.gcode, and the probe data file is probe.txt. So the first thing you'll note is the total Gcode time is 5,573 seconds. Total Gcode distance is 4.1 meters. Now there's two, and just like the hole drill, on the etch there's now two algorithms. I first had, I started with the Bilinear Interpolation. I can show you what that is. If I push K, so it has these this is the probe grid heat map. So red is the highest. Here's in the corner is the very highest. It's effectively 0, and over here is the lowest. Blue is low, and here in the middle of the black is the lowest at about -0.37. I was a little bit off earlier. But all it does, bilinear interpolation, is basically drawing a straight line between all the probe points. So that's not exactly the shape of an actual PCB. A PCB is rounded. So the other algorithm you can use is the bicubic spline interpolation. So if you've ever used CAD and you draw a spline, that's basically what it's doing, is it's making smooth splines. So now I'm going to use that undo command, U, and I'm going to hit L for the bicubic spline interpolation. So now what it's going to do, it's actually going to generate a more detailed heat map. So you can see the smooth, here's the original probe heat map, and here is a heat map that has that bicubic spline interpolation applied. Now, you can't really see any differences if you were to look at the Gcode in a tool, because it's such a small amount of difference in the Z height, but you'll see here that the Z has gone from, what was it earlier? It was at -0.08 millimeters from positive when it's doing a travel move, 1.5 down to -0.08. So now we're down to -0.45. Now, the other thing you can do sometimes, I want to drill I want to cut two boards on one PCB. So if I was to look at this Gcode, I'm just going to hit D for draw. Now, it's fairly small compared to the standard. I usually carry I think 5 centimeter by 7 centimeter PCB blanks, and this, I can fit a few of these onto one board. So what I'm actually going to do is I want to create 2 copies onto one Gcode so that I can go ahead and cut 2 boards on one go. So I'm going to undo, because we actually want to copy and then apply that leveling again. So I'm going to undo successful here. I'm going to hit C for copy, original Gcode. Now it's asking for the X offset. So I'm going to move it 31 millimeters to the right, 31, Y offset, 0, and then enter, done. So now we're going to hit D for draw, and you can see how there are 2 boards side by side. So the reason I wanted to do this before I leveled the board with the Z probe data is because the Z probe data over here isn't identical to over here. So you actually need to copy the Gcode before doing the leveling. So I'm going to close this. I'm going to hit L for level using the cubic spline, and done. So when I hit D, it looks the exact same. There's a little bit of difference in all the Z heights though. Now, The other thing to note about this is that it's very inefficient in regards to travel moves. So you can see the red lines are travel, the black is etching, there's red lines everywhere, and there doesn't need to be. So if I close this, there's a tool. If I hit E to optimize etch path, what it's going to do is it's going to start combining all the etch loops that it can. So I'm going to hit E. It's going through, it's combining as many as it can. This can take a second, but you'll see the effects. It's pretty apparent when it's done how much faster it is. So first of all, when I go up and I look at the distance, total Gcode distance is 8.4, about 8.4 meters. Now the total Gcode distance is 5.3 meters. So it's cut it down quite a bit, about 2/3. When I hit D, you can see how that works. Travel moves are significantly reduced. They're only where necessary. So to etch this little island here and etch this island, and most of this stuff, most of these etch paths are connected, so it actually etches them all without doing any travel moves. I think that is about it. So yeah, you want to check out how I do my Z probing. I have a video here. You can see how it goes in a path back side to side and just goes probe and generates all that data. So yeah, thank you very much. Feel free to use the program and have a wonderful day.